And so the next topic, guys, I want to now cover significant figures for Avogadro's number. So that will be 9.7, apart from your textbook. That will be on page 347, and 1 mole is equal to, again, 6.022, then to the positive 23. Now, this one is an exact number, and that means that this is an infinite number of significant figures. So we're not concerned with 1 here. What we're concerned here, guys, is with this number, and this number, of course, has 4 significant figures. And so this number came from the experiment. It is experimentally determined. And therefore, that will be the number that, if you do the calculations, the final answer will be definitely, guys, it will be affected by this number. Now, so again, we use Avogadro numbers for significant figures. Of course, more significant figures are available, but in this course, for our purposes, we are fine with 4 significant figures. Now, the next 9.8 part of the chapter is talking about the relationship between the molar mass and the AMU, which I already covered before, so you guys definitely should go to the video, to the part of the video to I guess revisit it. If you're still confused, you can also email me with the questions, and I will, go over again. And if you want to discuss more, I may try to do face-to-face some kind of, I guess, maybe through Zoom conference, or we'll find the ways for the more detail and better explanation. But again, the best way to communicate with me, guys, via email. So now, what's now the next part of the chapter? And that will be 9.9. 9.9, again, guys, I'm not skipping 9.8 because I already talked about it. So that will be on page 348. And so this one here is a very important one. This is a mole and chemical formula. So here, for example, if you're given 0.25 moles, let's say of C6H12O6, for example, and the question is, now what's the relationship between this compound, these elements in this compound, and this number of moles? You can always set up a ratio proportion again, or conversion, because all this is telling you that if you take the molecule by itself, you can always get the following conversion factor. You can say 1 mole of C6H12O6 always contains 6 moles of carbon. So that is the fixed composition here. This is a compound. Remember, compounds always have fixed composition. And as a result, that this 1 to 6 will be your ratio here, or conversion factor. Now, the next one, you can also say 1 mole of C6H12O6 will be equivalent to 12 moles of hydrogen. Now, again, that's what you do. 1, we don't show 1, but it's there, and will be 1 to 12 ratio. Now, 1 mole of the same substance, C6H12O6, now will be equivalent to 6 moles of oxygen. And so now all of these are conversion factors. Now, if you want to figure out how many moles now of carbon or hydrogen or oxygen in just 0.25 moles of this glucose molecule, all you have to do is just conversion. You got your conversion factors, given desired, you will get your final answers. For example, if I want to figure it out now, the number of moles, or I can abbreviate it as N of, let's say, carbon. I can do the following. I will always take what's given and put it first. And that will be C6H12O6, that's the compound given. And now I'm going to use the correct conversion factor right here for the conversion from the mole of the substance into the mole of the element. And then when 1 mole of the substance will come, of course, in the bottom here. and 6, and that will be equivalent to 6 moles of carbon. And then of course same units will cancel out. Remember, I'm not canceling the numbers, I'm canceling the units here. And so when I do so, I'll pretty much now get my final answer. And as you can see, guys, all of this chapter, the entire chapter, is just the conversions. And remember, we talked about it, the importance of chapter, I believe it was 2 chapter where we went heavily into the conversions. So that will be now 0.25 times 6 will be, of course, 1.5. And again, this is exact number because it tells you the number of, you count 1, 2, 3, 4, 5. This is the exact number. This is the measured number. So the final answer will be 2 significant figures, 1.5 moles of carbon atom. And the same thing goes, let's say, for hydrogen. The only difference is I'm going to use a different conversion factor here. But still, the starting material here will be my glucose molecule in the amount of 0.25 moles. And all I have to do now, moles, again, I always want to put this identity of the substance here so that I'm not confused. When I'm converting, I'm not confused what I'm actually getting in the end. And so I'm going to put now 1 mole of C6H12O6, and it will give me contains 12 moles of hydrogen, canceled. All I have to do now, take this number, multiply by this number, it's a quarter of this number. It looks like 12 divided by 4 is what? 3. And I have to pretty much put 0 here because 2 significant figures, moles of hydrogen atoms. And you can do the same thing, guys, for the oxygen. It's a good practice. But again, instead of now using this or this conversion factor for oxygen, is a unique one. 1 mole will be to 6 moles, kind of the same as this, of course. But again, you want to keep your conversion specific to a particular substance. So of course you're going to say now there 0.25, 1 mole will be in the bottom of the substance, so 6 moles of oxygen. So in other words, you will get 1.5 moles of oxygen also. And that's how you deal, guys, with conversion of given the amount of moles of a substance, and if you need to figure out how many moles of each element in a particular substance.